Obviously, when you understand the basic discrete random variable, like this becomes much more easier to interpret, like because this is also one of the discrete random variable. Now, binomial distribution is basically a distribution where you have been like generally given number of trials and certain probability of being successful on that trial. Now, let me give an example. Now, for example, if you're doing penalty shots, okay, so now as a player, I know what are the skills, average skill for a particular person to score a penalty. So based on the chances that the particular person has or can score on a given trial, you can calculate the chance. Okay, how many shots will he score if he takes 5 penalty shots out of 5, or 4 out of 5, or 3 out of 5? Because now when I say, let's say in a binomial distribution, like why we call it as a firstly binomial distribution. Now see, let's say you're taking 3 penalty shots, and I know the probability of hitting any of them is 0.7. So probability that you score is 0.7 here, 0.7 here, and 0.7 here. That's scoring all of them. So that's nothing but 0.7 cubed. That's one case. Now, if I ask a simple question is, what's the probability that you score on the first one, score on the second, and you miss out on the third one? So that's going to be score on the first is 0.7, score on the second is 0.7, and miss on the third is 0.3. So this is one obvious outcome that we already have. So that answer is basically 0.7 squared times 0.3, since your order is very much fixed. Now, if I ask a simple question, like consider this particular case itself, and now you'll notice that if I ask you a simple question is, let's say, what is the chance that a particular person just scores on 2 of them? Now, the moment you say any 2 of them, you get a random chances now. Now, I can score, let's say, on the first one, which is 0.7. I can score on the second one, and I can score on the, I can miss on the last one. That's one way. Or there's another way, which is miss on the first one itself, but score on the next one and score on the next one. And there's another way. You can miss on, let's say, this is 0.7, 0.3, and you can then score on this. So you got now basically 3 different possibilities. Like, the same answer will be 3 times 0.7 square times 0.2. So this is basically due to the binomial, combinations. So this is like you're choosing out of 3, you're choosing 1 trial to be like failing. The 3 choose 1. Or let's say you're being successful on 2. So 3 choose 2. So 3C2. So 3C2 means out of 3 trials, let's say you're being successful on any 2. Here it is not important on which one you're being successful, any 2. So if you have got, let's say, 10 different trials, and out of that I need to be successful on any 4. So it'll be 10 choose 4. So these are the different combinations, like the shuffling you saw, these are different combinations to be successful on any 4, and obviously remaining 6 are failing. Understood? So basically, this is the one factor, which is, I would refer it as NCR. That's your factor responsible for the entire binomial expansion. Okay. Now, the link to the binomial expansion, let's say if I have got expansion of a plus b to the power 3, or it will be easier to explain in terms of p. So p and q. Suppose if I expand this, I get pq plus 3p square q plus 3pq square plus qq. So pq plus 3p square q plus 3pq square plus qq. Now, this is the expansion of p plus q. Now, what does each coefficient represent? And what does each individual terms represent? Here is very interesting to understand. Now, suppose p is the chance of succeeding. So there is the coefficient 1 basically indicates that you can be successful on all 3 in only one way. You basically hit all 3 penalties. Second is p square q. Now it means that you succeed on first 2 and you fail on the 1. You succeed on 2 and you fail on the 1. And there are 3 likewise chances. As you saw, we had three different possibilities, like for two success and one failure. Like first was 0.7, 0.7, 0.3. Then it was 0.3, 0.7, 0.7. Same way it was 0.7, 0.7, 0.3 into 0.7. So this is basically two success and one failure. There are three other ways you can succeed on only one. So succeed on first, succeed on second, or succeed on third, and remaining two you fail. And then the last one is QQ, where you fail on all. So the coefficients, if you look at, coefficients are telling you that, okay, these are the different ways or combinations that you can be like making this product or this product. So basically, whenever you are doing binomial expansion, I'm just not going to be like focusing too much on this because it's a lot on calculator. But logically speaking, this is the base of binomial expansion or binomial theorem or binomial distribution that we talk about. So let us just kind of understand the main part, which is basically, let's say, the formula that we need. So firstly, what does it take for a distribution to be a binomial distribution? Number one is you should be given number of trials. So your number of trials should be given. So number of trials, generally independent trial. They should not be depending upon the previous one, or they should not be rigged or biased. So number of independent trials. So n is the number of independent trials, and you should be also given probability of success. So generally a binomial distribution is written as x distributed with binomial with number of trial comma probability of success. So n comma p. So if I say that, okay, x is distributed with binomial 10 comma 0.3, it means that I have taken 10 trials and probability of being successful on any of them is 0.3. So I've taken 10 trials and probability of being successful on any of them is 0.3 basically. So this is about the binomial distribution, like how to present it. Next is how do we manually calculate the probability? Now let's just try to understand. So let's say I'm taking 10 trials and I wanted to be successful on exactly 4 of them. Okay, so first let's start with all 10 of them. So probability of x equals to 10, let's say. So in 10 trials, I can be successful on 1, 2, 3, or none, or 10 on 10. So it should be 10, choose 10 is because you're basically all of them are being successful. And now you're being successful on all the trials. So it'll be like into 0.3 to the power 10, and you're failing on none. So 0.7 to the power 0. So the net power gets distributed amongst failing and passing, or failing and succeeding. So let's say if I want to be successful on any 9 trials, so we 10 choose 9 because out of 10 I need to be successful on 9 into 0.3 to the power of 9 into 0.7 to the power 1, because now I'm failing on 1. Similarly, if I wanted to be successful on, let's say, exactly, let's say 5 trials, or exactly like 4 trials. So this is going to be 10 choose 4 into 0.3 to the power 4 into 0.7 to the power 6. So this is the general outcome of that particular formula. So in short, the formula that we have is NCX p to the power x and q to the power n minus x, where q is the probability of failing, also referred as q equals to 1 minus p. So q is 1 minus p, and the formula is NCX p to the power x and q to the power n minus x. So this is how you basically do and interpret at least the manual way of the binomial distribution. Now you can see that there are none of the decimal points, like okay, what's the probability you're successful on 10.5 trials or 5.5 trials or that way. So it's not possible. That's why they are referred as discrete random variables. Okay. And more interesting is you should know how to do these things on calculator. You should know how to understand all of these on calculator. So now lots of times the trouble is that first thing which we did here was like, let's say if I had to do what's the chance of being successful on 4 trials? So you write down this at 10C4 into 0.3 to the power 4 into 0.7 to the power 6. But the problem here is that, like, sometimes you don't know how to evaluate the 10C3, 10C4 values. So you should know the formula firstly. The formula for NCR is n factorial over n minus r factorial times r factorial. So if you want to, let's say, do 10C4, it can be written as 10 factorial over 10 minus 4 factorial times 4 factorial. So 10 factorial is 10 factorial upon 6 factorial, which we can write into 4 factorial. Further, you can split this up. 10 factorial is 10 into 9 into 8 into 6, 7 into 6 factorial upon 6 factorial times 4 times 3 times 2 times 1. So 6 factorial gone, 4 2s are 8, 8 gone, and 3 3s are. So you get the answer as 210. But the problem here is that, like, doing this much can waste a lot of time for you. So there is a shortcut that you have on your calculator, which you can use on normal run matrix mode. So you run this, you have got option, then you press F6, and then you say prob. Option F6 and prob, you'll see the option NCR. So you just type out here, let's say 10, 10, 10C4. So let's say if you want to type out 10C4 here, the answer is 210. So 10C4 is 210. So you can see clearly that it saves so much time. But generally, even you don't need this part if this comes in purely calculator paper. So if it comes in calculator paper, you can just simply go here. Let's say you go on to statistics, and now you press distribution, go to binomial, go to BPD. So BPD is generally when you have got an exact value to calculate probability for, like, x equals to 4 or x equals to 5. BCD is binomial cumulative distribution. So, like, you have got a, like, range of values. Like, for example, the 4 to 7, this is called BCD we're going to use. So let's just do first, because first 3 are exact. So you're going to put BPD. So let's say here, sometimes you'll see this option like this. So you'll see list option. Generally, don't need list option, make it variable option. Variable, the X is basically 4, because I want to be successful on 4 trials. A number of trial is 10. So number of trial is 10, and probability of success is 0.3. So 0.3. So you get the answer as 0.2, which is somewhere around 20% chance. So there's 20% chance that you'll get 4 success out of 10. Now 10 out of 10, you just go and change the X value to 10. So X is also 10, number of trial is 10, P remains same, and your answer is close to 0. You can see that with this skill, probability of being successful is close to 0, because it comes to be 10 to the power of minus 0.6. Then we got X equals to 6. If you take number of trial, you remain the same. X equals to 6, you type out here, and then you get around 3.67% chance to get 6 success out of 10. Now the next ones are range of values, like X is between 4 and 7. So when you are doing between 4 and 7, you're going to do let's say the BCD now. So you go on distribution, binomial, and now press BCD. Here it'll ask you lower value put 4, upper value put 7. Number of trial remains same, probability of success remains same. So you get the answer is 34.87% chance. So 0.3487 is the chance of that. And next one is, like, let's say 1 to 8. Now sometimes if 1 is not included, let's say here I don't want to include 1. So let's say I want to exclude 1. So from there, like, more than 1 and less than or equals to 8. So more than 1, you will not start from 1 anymore. You will start from 2. So lower will become 2, and upper is going to become 8. Number of trial remains same, 10, and probability of success is 0.3. So you're going to get the answer as 85%. So your answer will be wrong if you take lower value as 1. So lower value has to be 2 because it's not included. So in binomial and discrete random variables, you need to be very careful about whether is the value included or not. as far as the normal distribution is concerned, you don't need to.